So my name is Kyra Mills-Parker, and I work for the Oil and Wildlife Care Network out of UC Davis. I'm the Field Operations Coordinator, and I'm here today to give you guys an overview of what we are, what we do, how we came about. So the Oil and Wildlife Care Network is really the wildlife arm of the Department of Fish and Wildlife, OSPR. But we are administered through UC Davis, the Wildlife Health Center, which I'll talk about here in a little bit. Okay, so today I'm going to first start off with effects of oil on wildlife, and then I'll go into OWCN history and a lot of other stuff, and how OWCN works within a spill, within the ICS structure. And finally, I will end with wildlife care procedures. So Holly did a great job of introducing some of the topics that I will be covering today. As a matter of fact, I could probably just sit down now because you covered a lot of them. Thanks, Holly. Oh, and I wanted to point out Stephanie, right here. She's the newest addition to our OWCN family, and she's right back here. We're happy to have her. Okay, so you guys have been talking about petroleum during the week. However, that is not the only type of contaminant that can foul feathers of a seabird or fur of a marine mammal. There's other contaminants out there, for example, hydrogenated oils, fish oils, vegetable oils, as well as other compounds. So, oil or not oil? Going back to Josh's. Not oil. Any idea what that is? Algae, yes. So this is algae. There have been a few very large algal events in California that have resulted in the death of hundreds of animals. Especially seabirds. This here is a loon. And so it contaminates the feathers of the seabirds. And it basically acts very similarly to petroleum products, which I'll talk about in just a little bit. Okay, so the primary effects of any contaminant, the initial impact is going to be external. So the animal swims through a contaminant, gets completely covered in whatever contaminant we're talking about. We're going to be talking mostly about petroleum. So the initial effect is going to be external. As soon as the animals feel like they have something on their bodies, they're going to try to bring that off, remove it. Whenever you have something on your body, you try to, brush it off. So it's the same thing with the animals. For example, this little grebe here, which is trying to remove this contaminant. And so the initial effect is going to be external. However, because of what they do, of trying to get that product off, they're going to have internal effects as well. Okay, so a little bit about feather anatomy. If you've really looked at a feather, it has very, very intricate details. Each feather has a very particular anatomy, and when a bird with thousands of feathers, those feathers are going to have this interlocking system that acts very much like a wetsuit. So first of all, they interlock something like Velcro. And because of that very, very particular structure, so these are just showing the different types, the different parts of the feather. This is a microscopic vision of the feather. And this is zooming in to see some of the parts of the feather, the anatomy. And so what happens with the contaminant is that it interferes with that very special interlocking structure. It disrupts it, and so instead of the feathers acting like a barrier, trapping the air, keeping the bird insulated and warm, water is going to be able to penetrate, and that's going to cause a lot of the effects that we see. Okay, so first of all, there's the loss of buoyancy. Like I said, the feathers or the fur, they trap a layer of air. And so if that is compromised, the anatomy is compromised, water is going to leak in, they're not going to be able to hold and trap air, and that's going to affect the buoyancy. So basically the bird, instead of sitting on top of the water, is going to sink. And so that causes several problems. First of all, they don't like to sink. They want to stay afloat. And so they try to compensate for that. So their metabolic rate is going to increase. They're going to start getting cold because there's going to be cold water seeping in there, making them hypothermic. Consequences of this are, first of all, decreased foraging. They're going to be spending so much time preening, trying to get that stuff off them, trying to keep buoyant, trying to keep warm, that they're going to have decreased foraging. So that's going to eventually cause starvation. Also dehydration. They're not eating, so they're not getting that liquid in them. They're going to become dehydrated fairly quickly. Increased metabolic rate, like I said, they're going to try to compensate for the loss of buoyancy, try to keep warm, and eventually starvation. So we work with all of this in the sense that birds, when they are suffering from starvation, dehydration, they're going to want to beach themselves. They're not able to stay afloat. They'll come to the beaches, which is good for us because we go out and we collect them. So that's what we're relying on. Oil also physically interferes with the anatomy of fur. So we're particularly talking about sea otters and fur seals here, which rely on their fur to stay warm. So if the oil penetrates that, it's going to have very, very similar effects to the feathers. And therefore, they're going to also become cold, start to, with the dehydration, starvation. So very, very similar effects. Okay, seals, sea lions, and walruses, when we're talking about these types of animals, mostly they rely on blubber to keep them warm. So they're less reliant on their fur. However, what I just said, fur seals and sea otters do rely on their fur, and the young, the pups of the seals and seals especially have a fur coating, and so they do rely on their fur as well. But for the most part, the larger animals have a layer of blubber. So a walrus that is coated in oil is not going to have similar effects, so they rely on their blubber. And so an external coating of oil on a walrus is not going to have a huge impact. It's also going to interfere with locomotion and dermal and internal effects as well. Okay, Cetacea and sea turtles. So whales, dolphins, porpoises, and sea turtles, we really have very little data on the effects of oil on these types of animals. A large chunk of the data actually came out of Deepwater Horizon oil spill in 2010, where there were quite a few cetaceans and sea turtles that were affected by Deepwater Horizon. So we have learned quite a bit during this event. The primary impact is thought to be internal. So a lot of the cetaceans and the sea turtles that were impacted by Deepwater Horizon, they were showing up on beaches. They appeared to be unoiled. However, when they did necropsies, they found that a lot of the impacts were actually internal rather than external. Cetacea in general appear to be less susceptible to oiling. They have a very, very thick epidermis, which seems to not allow the petroleum product to penetrate quite as much, and so it's not affected quite as much as, for example, in a bird. Dolphins in a captive setting have been known to avoid oil, so we know that these highly intelligent animals can sometimes swim around the oil or below the oil. And Cetacea observed swimming and foraging in oil during spills. The problem with Cetacea sea turtles is that they're air-breathing animals just like us. And so they can avoid oil to a certain degree, but they do have to come to the surface to breathe. If they come to the surface and they come right within where there's a patch of oil, they're going to internalize it, get it into their lungs, get it into their internal organs, and that's going to cause huge effects. During Deepwater Horizon, they actually did a comparison of the rate of mortality between areas that had oil and areas that didn't, that weren't affected by oil, and the areas that were affected by oil, they saw that dolphins were 5 times more likely to strand in those areas. Even though they didn't have, like I said, a lot of external oiling, they had a lot of internal damage. Okay, other primary external effects. Mucosal irritation, so the mucous membranes are those that line. Yes?
Sorry, I just want to jump in for a second. One of the documents that NOAA produced a number of years ago is a book on oil and sea turtles. Because there were so many lessons learned during Deepwater Horizon, it's not by. So this is one of the books that's up on the table all week, but there may be a new one coming out next year.
Great, thank you. So it's the lining of those cavities that are exposed to the environment. So because of the volatile compounds of petroleum, that it can cause burns in the mouth, in the eyes. So these are some of the other primary external effects. It can cause skin irritation, especially the more refined products are, they can cause burns on the skin. Corneal ulcers is another external effect. And then these affected tissues are predisposed to bacterial infection. Okay, so let's talk a little bit about internal exposure. A lot of you have taken HAZWOPER. This is repeated information from HAZWOPER. So the routes of entry of these petroleum compounds are ingestion, inhalation, and absorption. Same thing for humans. It's basically the same thing for animals. This is how petroleum can enter the body. Sources of this are, like I said, like I mentioned at the beginning, preening and grooming, drinking contaminated water when they open their mouths to eat their prey, and as well as contaminated prey. Okay, we also find that petroleum products can have central nervous system effects, especially in marine mammals. So harbor seals that were affected during the Exxon Valdez oil spill, such as this guy here, there were reports that they were tame, that they just sat on the beaches, that they were lethargic, and it wasn't that they were just tired or hanging out on the beach. It was that they had central nervous system effects as a byproduct of these petroleum products that they were exposed to. And the histopathological findings, so basically taking tissue samples, we were able to verify that they actually had damage to the neurons. Okay, another huge effect is malnutrition. So the contributing factors for this are, first of all, inability to find food. These animals are, they're already compromised. They have a hard time foraging. They're trying to stay buoyant, all of the other factors that I talked about. So they have a hard time finding food, have a hard time foraging. They have higher energy needs because of what I talked about, trying to stay warm, trying to stay buoyant. Poor digestion. This is also a byproduct of the internal damage already being caused by these petroleum products. Damage to the intestines as well, and of course, feather oiling. Preening, like I said at the beginning, is going to increase the chances that they're going to internalize some of these products. There's also severe respiratory effects, as you would imagine, especially with the more highly refined products that have a lot of volatile compounds. That can lead to pneumonia, fume inhalation, aspiration pneumonia, and in sea otters especially, what's called subcutaneous emphysema. So it's when the air gets underneath the skin surface and it causes a type of pneumonia. Primary reproductive effects, there's also quite a few of those. We find that some of the animals that have been exposed to petroleum products have an altered reproductive behavior. There's early embryonic death associated with this, decreased chick and pup survival, increased abandonment, and eventually all of these factors combined can lead to population level effects. There's also effects on the blood, both anemia, hemolysis, hemorrhage, and immunotoxicosis. So basically the proportion of the white blood cells is going to be decreased, which leaves the animals more vulnerable to disease. Okay, now we're going to talk about some secondary effects, mostly caused by bringing the animals into captivity. So the only way to help the animals that are oiled really is to capture them, clean them, and care for them in a primary care facility. However, that is not, the story doesn't end there. There are a lot of secondary effects that can be brought about just by keeping those animals in captivity. So in a primary care facility, and I'll explain a little bit more about what that is, but in a facility where we care for the oiled animals, often there's poor ventilation. You know, you try to maximize the space where you have these animals. They're usually crowded environments, especially if it's a large spill. There's poor ventilation. These environments are warm and humid. Of course, the animals are cold, so we have to keep the temperature of these facilities pretty high. And there's a lot of stress. These animals have been through a lot. So all of these things combined can lead to this very serious fungal infection called Aspergillosis. I don't know if any of you have heard of that, but this is something that once it's started, it's really, really hard to go back to the way the animal was before it got that fungal infection. The fungal infection mostly affects the respiratory system, and so, you know, this is a very large problem. Another thing that happens is feather and fur damage. These birds, these are common murres here, they're on a soft bottom pen. So there are a lot of changes, a lot of evolution in how we care for animals. We've come a long way. We used to keep them on just, you know, wooden boards, and what happened is that, you know, they defecate, and so this causes a lot of fur damage because then the birds just sort of sit in that. So now we have these net bottom pens that are actually raised a little bit above the ground, and so they're easier to clean. The fecal material goes through the netting, and so they're not sitting in that, but it really is very difficult to maintain good feather condition. Keel lesions, the keel is the chest bone that the birds have where the flight muscles attach, and it's very much pronounced. I don't know if anyone has ever felt the keel of a bird, even a chicken, you can feel it. In the birds that have low nutritional condition, this is even more pronounced, and so it's a pressure point, and so when the birds sort of settle down on their chest, this can cause severe lesions, which can be very difficult to treat as well. There's also pressure points in the feet, and this is called bumblefoot, and you can see it right here. So this is a very large problem in a facility, as well as hawk lesions. There's some birds, like these common murres, that actually sort of, they rest on their hocks, and so this can cause also a pressure point. There's feather impaction, so these birds, this is birds after they have been cleaned. They will do a lot of cleaning to try to reestablish that anatomical structure of the feathers, but in doing so, sometimes some of that feather material gets impacted in the gizzard, what's basically the gizzard, and can cause some issues. So ultimately, leave the animals out there, the result is going to be debilitation, eventually death. So we do our best bringing them into a facility, dealing with all of these other issues, but trying to get them back to normal into a clean environment. That is our goal. So there are several factors that actually impact survival of an animal during an oil spill. Some of these factors are the type of product that's spilled, whether it's a highly refined product or whether it's crude oil. So these are going to have various effects on survival. The species that are affected. Holly mentioned some of the most common species in California. Some of those are easier to treat than others. So for example, common murres are very hardy birds. They usually do pretty well in captivity. However, a loon is very, very difficult. Grebes are sort of difficult to keep in captivity as well. The weather is going to play a huge factor in how cold the animals are going to get before we're able to capture them. And where the oil goes, and all of the things that you guys have been learning about during the week. The condition of the animals is after the breeding season. If it's directly after the breeding season, most of the birds are going to be pretty weak because they are spent trying to raise their young. They're going to be in a lower physical condition, whereas if it's during a different time of year when they're nice and fat and happy. So these are some of the things that can affect survival. These are some other factors that can affect survival. The speed of capture. This is something as field operations manager, I try to emphasize with the people that are on my team. We have to get the teams out there as quickly as possible, get to these animals as quickly as possible. That's going to increase their chances of survival. The availability of a facility is, are the birds coming in, are the animals coming in? Close to where there's a primary care facility or far away, is it going to take a long time to get those animals into care? And trained personnel and preparation. How prepared are we? How quickly can we get those teams out there? How quickly can we get them to care? So these are all factors excuse me, that can affect survival. These are factors we can do nothing about. They're already set. However, these are the factors that within the Oil and Wildlife Care Network and OSPR as well, we really try to work on those factors because they're things that we can influence. Okay, changing gears. So, just a few days ago, there was a large event, a large anniversary, 25th anniversary since the Exxon Valdez oil spill. And this is big. Exxon Valdez was a huge, huge event that had a large impact on not only California legislation, but legislation within the U.S. So there's two events that I'm going to be talking about that really deal very directly with legislation and the formation of DFW OSPR as well as the OWCN. Okay, so the Exxon Valdez oil spill happened in Prince William Sound, Alaska on March 24th, 1989. It spilled 11 million gallons of crude oil into Prince William Sound. Was one of the largest human-caused events ever to happen. And we all remember where we were at the time that this happened. Well, not all of you. I do. I'm aging myself. So even though it was very large and very memorable in our minds, it really ranks way far down on the amount of product that was spilled. It's actually in 35th place, which is pretty amazing that it's so far down, and yet, our minds have made it into this huge, monstrous event. But what made this spill so crucial for what was to follow were several factors. First of all, the U.S. lacked adequate resources at the time, especially federal funds, to respond to a spill, especially a spill of this magnitude. The remote location of Prince William Sound, only accessible by helicopter or boat, made it incredibly difficult and taxed the existing response mechanisms. And the huge diversity and quantity of wildlife. Prince William Sound is just an amazing habitat for what I call the 4 S's: salmon, seabirds, seals, and sea otters. So the devastations, the impacts to wildlife were tremendous. The estimated impacts, so this is not a number of animals collected, these are estimated. The projections of how many animals they think were impacted: 250,000 seabirds, 2,800 sea otters, 300 harbor seals, and 22 killer whales. So just absolutely huge. The other event that is noteworthy in this story is what's called the American Trader oil spill. How many of you have heard of it? Okay, so quite a few, that's pretty good. So this was a single hull oil tanker that actually ran over its own anchor on February 7th, 1990, and it spilled 400,000 gallons of crude into the ocean near Huntington Beach, so not too far from here. 3,000 to 4,000 birds were killed, and 600 birds were rescued, rehabilitated, and eventually released. Okay, so the Oil Pollution Act amended the Clean Water Act and addressed a wide range of problems that were associated with preventing and responding to oil spills. So there were several things that came out of this legislation. One was that it really it expanded the government capacity to respond to oil spills, which was really terrific and much needed. It put aside a separate pot of money to be able to respond to spills. It revised contingency planning. It required planning for the worst case scenario. A lot of us take part in these spill drills for the worst case scenario spills, so that is a direct follow-up based on this act. And it required a specific wildlife response plan, like Holly mentioned earlier. So this is the language: provide for a specific wildlife response plan to minimize disruptions to wildlife and their habitat. And this was crucial in setting up OSPR as well as the OWCN. So OPA 90 was great legislation, greatly improved our capacity to respond. But California wanted to do better. California thought that it wasn't enough. And so the Lempert-Keene Sea Strand Oil Spill Prevention and Response Act went a step further and created a Department of Fish and Wildlife, OSPR, so a particular group whose task is to respond to oil spills in California. It required rehabilitation stations for animals that are impacted by oil spills, and it established a research program to try to respond, to be able to deal with oiled wildlife better, so always improving. Okay, finally I get to the OWCN. So the Oiled Wildlife Care Network is a network organization that exists throughout the state of California, and it is unique. We're way above, way far beyond anywhere else in the U.S. in terms of oil spill response on the wildlife side, and we're very proud of it. So the administration of the OWCN sat within OSPR between 1994, when the OWCN was created, and 97. But when a research component was added to its mandate in 1997, it transferred the administration to the Wildlife Health Center at UC Davis. And that is the base of our operations. And there's 8 of us that sit in Davis, but we are a network organization with 31 member organizations throughout the state. provide the best achievable capture and care to oiled wildlife. The capture part was added after the Costco Busan oil spill in 2007, so that part of the mission is fairly new. Our funding comes from interest generated from the Oil Spill Response Trust Fund. The oversight of the OWCN is by an advisory board and a scientific advisory committee. The advisory board provides recommendations to the administration of OSPR regarding the operation, maintenance, and fulfillment of the mission of the OWCN. And it's composed of representatives from the oil industry, wildlife rehab organizations, and academia. And the Scientific Advisory Committee evaluates research proposals. Like I said, the structure is a network organization made up of over 30 member organizations. And our programs are what we call the 4 Rs. So readiness, response, reaching out, and research. Okay, so 31 member organizations, actually 32 after the last advisory board meeting. We just added a new organization. So there's rehab organizations, universities, NGOs that are part of this. And there are 3 different types of organizations: primary care, stabilization, and personnel. The primary care facilities are those facilities that have the capacity to take an oiled animal from the environment, clean it, rehabilitate it, and release it back into a clean environment. Stabilization facilities don't have that capacity to clean an animal and rehabilitate it. Stabilization facilities are basically the intermediate step. So they take an animal, stabilize it, and then transfer it to a primary care facility. And personnel organizations are those that just provide personnel to the response. So the agreement for these member organizations, there's actually a memorandum of understanding between the organization and DFW, OSPR, and OWCN. So the organization itself agrees to provide rapid and cooperative response, and OSPR OWCN agrees to equip, supply, and train those people. And in addition to that, we provide money to develop and maintain multi-use facilities. So here's the map that has our primary care facilities in orange here and the member organizations. Like I said, there's the 3, the primary care, stabilization, and personnel facilities. In this region, so we have 13 primary care facilities. In this region, SeaWorld San Diego is our primary care facility. Actually 12 primary care, 11 stabilization, and 7 personnel. So the primary care facilities, especially, they're what we call multi-use facilities. So these are basically rehabilitation groups that occupy the primary care facility. For example, there was a question about Cordelia. That's the best known because it's actually been involved in a lot of the oil spills, like Costco Busan. And so there's the International Burn Rescue, which is a rehabilitation organization that occupies those buildings, has regular rehabilitation of wildlife, but the agreement is that during an oil spill, they have to transfer all of those animals out of that facility and make it available for animals to be received that are part of the oil spill. So this reduces spill startup time because they're always testing out the pools, the pump systems, everything else because they're using them on a daily basis. It provides cost-effective maintenance, and during non-spill use, it's used for rehab, education, and research. Okay, we have basically 3 tiers of personnel. Convergent or spontaneous volunteers are those that are people, members of the public, people that come off the streets when there's an oil spill and say they want to help. The OWCN has trained, given this basic information and safety training to about 5,000 convergent volunteers. The second tier is what we call our pre-trained volunteers. We have currently about 2,000 of those. In all our times of operation, we've trained about 4,000 volunteers. And these volunteers have a higher level of training than just people coming off the street. So they go through our webinar series and they attend our annual rehabilitation conference, which was actually held right here last October. And then the third level of personnel is what we call our staff. So basically they have the highest level of training. They're the ones that have gone through the HAZWOPER training. They have the level, they go through the level what we call level 2s, level 3s for the wildlife recovery, hazing, field stabilization. So these are the people that we first call on. Some of them actually function in supervisory levels during low spill response. All in all, the OWCN has responded to more than 90 oil spills. This includes within California, nationally, and internationally. We've treated about 10,000 oiled birds and mammals, and some of the most notable oil spills that we've been involved with have been Costco Busan, Dubai Star in 2009, Deepwater Horizon, and the Reno oil spill in New Zealand in 2011. Reaching out, this is one of our R's. So basically we try to spread the word about what we do, why oil is so harmful to wildlife, through seminars, presentations that we give, public outreach. We have a website, we have a blog, and we have a newsletter that comes out every year. We provide national as well as international assistance, and this includes facility development, response planning, and spill assistance. Most recently, we've been helping out some colleagues in Mexico. They're developing a wildlife working group, and so we're actually going there next month to provide some training. In terms of research, like I said, we're always looking for better ways to treat wildlife. That's part of our mandate, best achievable care to wildlife. So better understand the effects of oil on wildlife, how best to care for the wildlife, and post-release survival. So this is basically tracking studies, because if we don't know what happens to the animals after we release them, it could be they all die, which would really be a bummer. But we're really trying to emphasize the importance of post-release tracking studies, so we're very active in trying to promote those as well. So over 140 projects have been funded by the OWCN since 1996. Every year we give up to $250,000 in research grants, and 3 post-release projects have been funded since '97. We also have a fairly active in-house program for doing the same thing. So the 8 core staff that are in Davis are also very involved in doing research as well. So these are some of the studies that we've been involved with. The soft-sided pens to prevent injury to the birds. We used to use some that have really hard sides, and sometimes the birds were getting injured with those pens. So soft-sided pen study, nutrition and fluid studies, always trying to better treat the animals. The effects of being housed in fresh water. If you take a seabird and you put it in fresh water for long periods of time, it doesn't do very well because they're used to the salt, so they need, salt supplements. And so there's a lot of research into how to best care for seabirds. Also, this is a picture taken with an infrared camera to look at the waterproofing of seabirds. So these red areas, this is a common myrrh. These red areas are the hot areas, and the blue are the cold areas. So you can see around the neck, it's relatively cold, and further down, it might not be completely waterproof. So that's one of the studies that we have ongoing. Testing satellite transmitters for the post-release studies that I was talking about. And most recently, we've been looking at the effects of dispersants on waterproofing. Okay, changing gears again. How's everyone doing? I'm almost done. This is the last part. I know it's a lot of information. Okay, so now what I'd like to talk about is how the Oil Wildlife Care Network fits within the ICS system, which Holly covered a little bit about that, and the different groups. So I might skip over a little bit of what Holly covered. So this is the org chart that I found in some old presentation that was given about 10 years ago or 12 years ago. Anyway, it was very simple. And that's why I like to show it, because it's much more complicated. They had the Wildlife Branch Director, the OWCN Response Coordinator, and then Search and Collection, which basically now we call Wildlife Recovery, Intake and Processing, and Wildlife Rehabilitation. Today, these two are combined into what we call Care and Processing. So, this is what it looks like now. It's a little bit more complicated. So, as Holly mentioned, the Wildlife Branch Director, the Wildlife Branch sits under the Operations section. Usually when we go to spills and drills, the Wildlife Branch sits in a corner because there usually is not a space set up for wildlife, and we have to say, hey, we're here. And so they say, oh, you can go to that corner. So, but we are a pretty prominent feature within spills and drills, and we have a huge support network underneath us. Here are the groups: the Reconnaissance, Hazing, Recovery, Field Stabilization, Care and Processing, with all the various levels below them. The Oil Wildlife Care Network manages those 4 groups. And then this is the part, even the slides are the same. So the Reconnaissance Group, as Holly said, evaluates the numbers, the species, and the locations of impacted wildlife. The Hazing Group deters the wildlife from getting oiled. So the best way to treat oiled wildlife is to prevent it from getting oiled in the first place. So hazing is a group that doesn't always get activated because it's very, very tricky. You don't want to scare wildlife into the oil. You want to scare it away from the oil, but if you are not careful, it's very easy to scare them into the oil, which is not good. So pyrotechnics are used in these propane cannons, but like I said, hazing is a group that is not always activated. It's just very, very particular circumstances. Wildlife Recovery Group is the group that goes out to actually do the collection of live and dead animals. Every live and dead animal gets cataloged, used as evidence for the spill. And so, yes, we prioritize the live animals because we need to get those to care as soon as possible. But we also instruct our field crews to collect every single dead animal. And this is not only for the evidence, but we also want to prevent secondary contamination by predators and scavengers. Field Stabilization is the newest member, the newest group that only got added about a year ago. So as in the stabilization, the brick and mortar structure, field stabilization is very similar in that it's that intermediate step between the capture and getting an animal to primary care. So what we know is that the sooner you get that animal warmed up, give them fluids, get them in a quiet space, try to reduce their stress, the better their chances are going to be for their survival. So this is basically providing first aid to animals, especially if the primary care facility is far away. So as you saw with the map, we have 12 primary care facilities and a huge coastline to cover. And so field stabilization provides that intermediate step. We now have this trailer called the MASH, the Mobile Avian Stabilization Hospital. It has to have a cool acronym. And so this is a trailer that we can provide that first aid and then transfer them once they're stable. The care and processing group collects the evidence from all live and dead animals that comes into the facility and provides the medical care to the affected animals. So when an oil spill happens, these are the basic steps. Notification of the event. We can either get put on standby or immediately activated, and I'll go over this in a little bit, or go from standby directly to activation. From activation, we go into the response and finally demobilization. Okay, so notification comes usually through OSPR, directly through OSPR, with a phone call or a text. It can also happen from the responsible party itself, but that would need approval from OSPR. And the public or the member organizations can call this hotline and tell us we're seeing, hundreds of oiled animals coming to the beaches. So that's when we start mobilizing and calling OSPR and trying to figure out what's going on. Okay, so activation is based on the presence or the likelihood of animals getting oiled, and Holly covered a little bit of this. This is from the reconnaissance. If there's reconnaissance out there that can actually see if there's large racks of birds or rookeries or large numbers of animals in the location of the spill. It can come from field reports or people that are knowledgeable with the area itself. The mechanism of activation is usually through the Wildlife Branch Director. The responsible parties can activate, but like I said, they must have OSPR approval. They can notify us, but they have to have approval from OSPR to activate us. Okay, steps to a response. These are the various steps: recovery and transport, going out, collecting the animals, transporting them to either field stabilization or care and processing. Here's field stabilization. Once they get to a facility, they go through processing and intake, pre-wash care, and I'll go over these steps in a little bit more detail in a little bit. Cleaning, conditioning, and release. Okay, so field operation procedures. The correct field operation procedures are effective in reducing impacts by hazing an oiled wildlife away from the areas of oiling, capturing individuals that, if left to their own devices, would probably perish, maximizing the survival rate of the animals, and, like I said earlier, increasing the safety of the scavengers and the predators that, in seeing all of these, it's like a buffet, seeing oiled dead animals on the beach. They are attracted to them, but we try to minimize that, cleaning the beaches so that those scavengers and predators don't get oiled as well. Okay, the processing refers to the legal documentation that occurs at the primary care facility. So this is very important to collect all of this information in a very logical fashion and a standardized fashion. So information on where the animal was collected, there's always a photographic record, such as this right here, the scoter. There's a feather sample that is always taken. That feather sample, if needed, can go to the petroleum chemistry lab for identification, for identifying that particular product to a spill. And the animal is given a light band at the time so it can be followed through the procedure. Both live and dead animals are cataloged. Intake is the process of basically starting the record, the medical record of that animal. There's a very quick 5 to 7 minute examination, since you try to maximize the time that you try to be quick about it. So they're given a very thorough examination, but it also has to be quick, especially in large spills. All systems are looked at, the degree of oiling, temperature, and weight are taken, a blood sample is taken, and like I said, this has to happen within 5 to 7 minutes. Pre-wash care. A lot of people have the misconception that you get an oiled animal, get it washed as soon as possible. So that is not the case. That is, if you take an animal, and this is something that we found out the hard way, mostly during Exxon Valdez, if you take an animal, you wash it immediately, it usually dies. That's because it's incredibly stressed out. You actually have to give it a little bit of time for it to relax before you move it to the wash, which is the most stressful process. So pre-wash care basically is getting the animals heated up, giving them fluids, and testing their blood and weight every 2 days or so. We usually wait about 48 hours before approving them to go to wash.
Before washing, is there a way you can keep them from ingesting the oil that's still on them in those 2 days?
No, not usually. And you probably have all heard about the canoe sweaters, which are adorable, but they don't work very well. You don't want to put a sweater on an animal and have that petroleum really close to the skin where it can cause irritation and all sorts of other problems. So the cleaning, like I said, is the most stressful process. Rinsing, the wash itself has to be done under high pressure. And it's really pretty amazing if you've ever washed an animal, because you get all that stuff off of it. When you get everything off and as you're rinsing them, it's called drive-by washing, which doesn't sound right, but you actually see the feathers realigning themselves and they look dry, even though you're, spraying them off with a hose. Anyway, it's hard to explain. And then it's really important to not only get all of the contaminant off of them, but all of the soap. Because the soap, if you leave any little bit of soap, that's going to be a contaminant and cause the waterproofing issues. Pre-release conditioning. So this is where the humans have done their part, and now the animals have to do their part to regain their waterproofing. You put them out to the outdoor pools, and this is where they do a lot of preening, realigning of the feathers. You give them time, you give them nutrition, and before they're released, they go through a very strict pre-release exam where the veterinarian looks for whether they've regained their waterproofing, if they are exhibiting normal behavior. The physical exam has to be normal. The blood work has to come back normal. They're given a federal ban so they can be tracked. And this is also the time to think about the post-release studies or the tracking. And then finally, release. So we, like I said, that we have come a very long way in improving our methods of getting the animals through this very stressful process. And we've gotten so good at what we do that out of all the animals that come into rehab facility, 50 to 75% are actually released back into the wild. This is a shot from the Readiness oil spill in New Zealand with the little blue penguins. So finally, what makes a response successful? First and foremost, it has to be safely conducted. If anyone gets injured out there, it can shut the operation down, and the animals are going to suffer. So this safety, of course, is of utmost concern. Rapid, efficient, and collaborative initiation. Not only initiation, we try to get our teams out there as soon as possible, but continuation into the response. We try to return the animals back to a clean environment. Even though this is a very stressful part, our goal is to try to return them in as normal state as possible back to the environment. Provide best achievable care to animals, and learn how to better respond in the future. After every drill and spill, we have what we call a hot wash, which a lot of you probably know about. So this is really where we bring up things that went right, things that we can change, and things that we can do to better respond in the future. And finally, better understand the impact of oil spills on wildlife. We know a lot of what the impact of oil is on wildlife, but we still have a long way to go as well. So thank you very much for your attention, and I'm happy to answer any questions. And feel